So one of the very widely used tool to do encryption and decryption is called OpenSSL. That's the link there. You can download it. It works in any platform, the Windows, Mac, Unix, and so on. And it implements so many algorithms. You can see the list of them by using this command I showed you last time. So many algorithms and so many kind of modes of operations of those algorithms. That's why you need to understand the most useful ones and the advantages and disadvantages of each, so you can select the most appropriate for the scenario you have at hand. Then for encryption and decryption, the most important command is this one, OpenSSL encrypt. If you want to get a refreshment, what are the parameters, you can do OpenSSL encrypt dash help. It will give you what does it expect. Now, part of the encryption, as we all know, we need to have a key. There are many ways of generating the key, as I explained before. One way is to generate a random number, a key using a random number generation. So to do so, you just do OpenSSL and you say, go ahead and do a random number generation of an hexadecimal number in hexadecimal format, and I want it to be 8 bytes. These are bytes, not bits. 8 bytes, which means 64 bits. And it gives you this number. This could be your key, and you can use it on both sides to encrypt and decrypt. So this is a very easy way to generate a key. A much better way, and this is more used in practice, is you basically derive a key from a password or a passphrase. And there are algorithms to do this. And these algorithms are called password-based key derivation function. Password-based key derivation function. Now, the way you do so, in here, for example, I am asking, please go ahead, create a key for me that will be suitable to use with RC4. And don't worry about this stuff, I will explain later. And don't use any salt. I will explain what this salt means. So if I just take this command here, or take this script and run it, it will create for me a key based on this password called secret. Yeah. And in here, I don't want, I'm putting this -p uppercase. I'm telling the OpenSSL, don't go ahead and decrypt or encrypt. Just give me the key. That's all I want. And I want the key to be hashed using this algorithm, SHA-1. We will see this later on. And I don't want to use any salt. I will explain what this salt means. So if I do this, I get a key. This key now is suitable for RC4. Yeah, I can go ahead and share this key with the other party, maybe call them or send this by SMS or send this by courier or whatever I want to do. Later on, we will see how to exchange the key securely. So this is how I create the key. Now, if I remove this no salt, have a look what happens. So you give me this salt number, and then it gives me a key. If I run it again, you see here the key is different and the salt is different. So what does it mean? What is this salt idea? What is a salt in the context of cryptography? You asked me last time, yes? What do you think? When I run this, this is the key. It ends with 3A. If I run it again, same key, exactly the same key every time, based on the same password. If we agree, instead of changing this key, I can just call you and say the password is secret. Generate your key based on that. Yeah. Now, if you generate it, you must use no salt, so you get the same key as me. You clear on this? So when I call you, instead of giving you this long, scary number, you need to have a key to encrypt and decrypt. Are you following? So instead of sharing this key, I share with you the password. Yes? And then you generate the key yourself based on the password. Using this command, both of us, we will go ahead and say, OpenSSL, please go ahead, generate for me a key based on the password secret. And I want you to use no salt. You do this at your side, you get this key. I do this at my side, I get this key. This is a very good news. Yes? We both use the same key, no problem. Now, so basically, when I say no salt, what does that mean? When I generate a key with no salt. Sorry? So basically, same password generates the same key. If you use no salt, same password generates the same key. It's clear? Now, when I remove this, every time I run it, I get a different. Every time I run it, I get a different salt and a different key. Have a look. How this key ends with A9, and this key ends with 95. Although I'm using the same password, every time I'm getting different key. So what's going on here? Why is it different each time?
It's like a seed or something.
No, not seed. Basically, what is a salt? Can you see here?
Like a rain.
Sorry? No, not range. Thank you. It's just a random number. So salt is a random number. What do I do with the salt? What do we do with the salt?
Mix it with
Yes, we add it to something else. In this case, what do we do with this salt? We add it with? No. What is our goal? Our goal is to generate the key. So what do we do with the salt? We add it to the password, and then we concatenate both and generate the key. Are you following? Yes? Now, when I want you to generate the key, what should I give you? For both of us to get the same key, we have to use the same password and the same salt. Now, if I use the same salt, let's see, is it opening? Is it doing? Yeah, very good. Can you see here? When I use the same key and the same salt, what do I get? The same key. You follow it? Yes. Now, if at your side to be able to generate the same key, what should you have? Same password, same salt. Yes. Now, the password, I will call you and say the password is, in this scenario, secret. Do I need to give you the salt? But the salt, I don't. If I give you this scary number, I would have given you the key and khalas. Why should I bother ourselves? The salt, I can send it to you plain text. And the enemies, they will never be able to generate the key. Why? They don't have the password. So the salt is the salt secret? No, the salt is not secret. But of course the password is secret. So what I do, we agree on a password. Whenever we want to generate a key, I send you the salt, or you send me the salt. As long as we agree on the salt, even if the attacker or the hacker or the eavesdropper gets hold of the salt, will they be able to do anything? No way. They cannot do anything with it. Are you following? So in cryptography, we try to keep the secret as small as possible. When I call you, I'm not going to take 5 minutes of your time. In 1 second, I'll tell you the password is this. And by the way, every time we want to communicate, we can use different key. We agree on the password once, maybe once every 10 years. We won't change the password. But every session we communicate, we can use different salt, which means we can use different key. Are you following? And the hacker will never be able to generate the key. Not only this, more importantly, why people invented this idea of salt. Because if you use the key, if you use just the password, there's something called dictionary attack. Dictionary attack. What dictionary attack means? Before, people used to use dictionary to get words and then use them to generate keys. But now there is even much more sophisticated ways of doing it. You know, when there is some kind of hack to some database, like Facebook or Twitter or some huge organization, they get the password from the database, millions of passwords, or even billions of passwords. So you get all the possible passwords that people think of out there. And what they do, they take the password and generate the key based on generate keys based on those passwords. And they get the key and they can try these keys to decrypt. Are you following? What type of attack we call this? No, we call this dictionary attack. This is not brute force. I'm not going to generate all possible passwords. That will be brute force. I'm doing it smarter way, getting a database of passwords, realistic passwords that people really use, because people, when these hackers hack some website, there is something called dark web. Everything is shared in there, and you can download these passwords and generate keys. It's much better than brute force. Yeah, you follow it. Now, if we use salt, are we still vulnerable to dictionary attacks? No, because every time we generate the key, what else do we use with the key, with the password? The salt. Is clear?
But the salt is public, right?
The salt is public. Yeah, okay. The salt, this is very good. The salt is public, but to make it more secure, every time we communicate with it, we use different salts. And because the salt is the random number, this hacker will have so much hard time. Not only they have to use the hacked password or dictionary, they also need to generate random numbers. And this random number is very big. How many? Maybe 64 bits. That's 2 to the power of 64. Back to, they take years to break this. And by the way, every session, even we exchange one message, I'll send you the message, I'll send you the salt. And by the way it works, really, when I encrypt a message, I give you the encryption with the salt. How do you decrypt it? You generate a key based on the salt and the password, and then you decrypt. Every time, that's why every time I run this, let me show you. This is the last thing I will let you go. So let me just show you this. Here it is. Here is the encryption. Okay, have a look at this. So whenever I do encryption, there is a salt get generated, and this is the key. Yes? Now, when I encrypt, what I'm encrypting, I encrypt the text. And what I append to the text, the salt. When you get the message, what you need to do? Extract the salt, use it with the password to generate the key, and then decrypt. So the hacker will, or the eavesdropper will get the salt, but will they be able to generate the key? No way. Yeah? So when I have a look at this, have a look at this key, and then I'll go ahead here and decrypt. -P, just to show you here. Have a look. Exactly the same. Different salt? No, same. Yes, same salt and same key. Where the recipient, where they get the salt from? Where the recipient received from the file. Which file? The ciphertext. So the salt go with the ciphertext, no problem. We are not worried even if the salt is discovered. The salt is not secret. The salt is not secret. By definition, what is the salt? It's a random non-secret number. It's a random non-secret number. What do we use it for? To make key generation much stronger. To make the key generation much stronger. And also we minimize what is shared between us, the recipient and the sender. What is shared between them? Here, not even the key, password. Because it's easier to agree on password rather than a key. Yes? It's clear? And by the way, every time I run it, I might get a different key, which is very good. Every session will have different key. Every time I send you a message, is a different key. That's the power of using a password and using a salt.